Good morning. Today we are going to discuss another important operating system concept, which is the semaphore. Which is a semaphore. Semaphore is a variable. Semaphore is a variable and it is used for synchronization. That means, suppose that if this x is a shared variable and that variable is shared among different processes or threads. Then at the same time, suppose that many readers are reading this value. That means these are all readers. Readers are, suppose that the value of this is 10. This is x is an integer variable and this is a shared variable, and that variable is shared among different processes or threads. And suppose that many processes or threads are reading the variable, and at the same time if they are reading the variable there is no need to lock it. That means reading is non-destructive. That means the content of or the value of this is not modified. So at the same time you can have any number of readers. But suppose that some process, this is a writer. That means this process wants to modify the content of this. Modify the content of this. Then that means if this wants to modify the contents of this, then the readers are not allowed at that point. If this writer wants to write something, then all these readers are prohibited from reading this value, and after this writer modifies this value, then only these readers are allowed to process that. That depends on the context. And anyway, this is the reader writer problem. At the same time some readers are reading and at the same time some writers are writing. That means there is inconsistency in data. That means the data that is not a dependable one. That means that is inconsistent. So these type of synchronization problem can be solved by using readers writers problem and the algorithms for that we might have studied earlier. So at this point in time, I am going to discuss the concept of semaphore. Suppose that you want to enter some critical section of a particular program, or if you want to access the shared variable, if you want to access the shared variable or something like that, so that can be done using a shared variable which is called as semaphore. Here semaphore means this semaphore is a shared variable, and the this is actually an integer value. This is a pointer to an integer. Those are separate data type is designed for that, which is called sum t, and star sum means this is pointing to this type of a variable, maybe an integer variable. Okay, so that is, so integer sum in it means, suppose that if you want to create a variable, so initially we are going to have sum t star sum. That means you are going to have this type of a variable you have defined, and if you want to initialize that semaphore variable, if you want to initialize that semaphore variable, then you can make use of this sum init function, and in that sum init function you have to pass the name of the semaphore variable. Then this integer value you have to pass. If this integer value you are going to pass is 0, that means that is shared among threads. It is not for inter-process communication. Inter-thread communication only we are using this semaphore. That's why we have 0 here. If it is 1, that is shared between processes. That means if it is shared between processes, that means processors are not interconnected, they are separate entities, then that semaphore should be located in shared memory portion of the kernel. If it is a thread, that means if a process is creating another thread, then that thread can access the variables of that process, and in that case that shared variable or this semaphore variable should be there in your program or some shared portion. Okay, but if that semaphore has to be shared among different processes, that means if this pre-shared value is 1, that means that semaphore variable should be located in the shared memory portion of the kernel. And unsigned value means this is initially assigned a value. For example, suppose that this is some t. Say I am going to have a mutex variable. So I am going to have 70 mutex. Then I am going to have some init, say mutex 0 comma 1 means, here the meaning is, here I have a semaphore variable mutex and I am going to initialize this it as using mutex 0 comma 1 means mutex is a semaphore variable and it is shared among threads, and the initial value of that is 1. Initial value of that is 1. That is the code for this one. That means if it has to be shared among different processes, then this should be 1. And if it is 1, this mutex should be a shared memory variable. Shared memory is, that we will discuss later. This is for creating or initializing a semaphore. This is for initializing a semaphore. Then how will you use a semaphore variable? Usually we are using binary semaphore. That means it is taking only two values, 0 and 1. A binary semaphore is having only two values 0 and 1. 0 means it is low and 1 means it is unlocked. That means if you want to acquire a variable, it is just like a key. If you want to enter a room, you need the key. Using that key, you are entering the room, you do something there, then afterwards you are exiting from that room, then you are locking it, and that key is and you are putting in some place. Then now the meaning of that is some other guy can use that. This is just like that concept. That means if it is a mutually exclusive event, that means if some resource or some portion can be used by a single process at a time. So for doing that, you have to acquire that lock initially. Just like our room and door example. If that door is locked, that means nobody is able to enter the room. That means some other guy is using that room and we have to wait. Once the person inside that room completes his work and he is exiting that room and that lock is put in some place. After locking it, he is putting in some place. Then all the persons or all the processes who wants to enter the room can acquire that lock, then unlock your door and enter the room. Okay. So that is the principle. That is the principle. Initially, here what it does is initially the value of this is 1. That means initial value of a semaphore is 1. That means that is unlocked. Anybody can acquire that. And initially, if you want to acquire a semaphore, and if you have given that, what you are going to do is you are waiting for the semaphore, and if it is allocated to you initially, the value of that semaphore will be 1 and you are going to decrement that value to 0. Then other processes who are willing to acquire that log, when they are reading that value, the value is 0. and they are waiting, and then we are waiting. That is why initially, if you want to acquire or if you want to acquire a semaphore, you have to execute this sum wait function, and in this sum wait function, this is waiting for the lock. If it is unlocked, then you have to lock it. That means this what this does is it is waiting for this to be 1, and you are going to decrement this sum is decremented, you do the job, and after that you are posting it. That means posting means uh, once you do that, and after that you have completed the job, and after that you are incrementing that and using this sum post. That means when some process is using a semaphore, that means using a semaphore means other processes cannot enter that section at that time, or that is a shared area, and that the process which is having this semaphore only can enter that area. And once he or she that process has completed execution of that particular portion, and its job is done, and then afterwards that semaphore is not useful for it, so this unlocking that means again incrementing the value of this after using this. So that is by using this sum post function. Sum post means is incrementing the value so that others can use that. So this is the concept of semaphore, and this concept is used in our examples 4 and 5. And in example 4 and 5, the concept of semaphore and threads are used. So earlier we had a discussion on threads, and now this is the concept of semaphore, sum post and sum wait. This is for initializing the semaphore. Then sum post is for unlocking it, and sum wait is for locking it. Okay. Thank you.